Hi, I'm an old guy and I do maths. Today we're going to start with a blank page. Now, you will be watching this video because you saw the header on YouTube and you clicked on it. And it's a problem today, a geometry problem I guess you'd call it, because it involves shapes. And how we're going to approach this is the way that I normally approach a problem such as this, which is I draw it. So I'm going to do a rough sketch of what we have, and this is very rough. So it looks like this, and we have an angle in here of 125 degrees. That is labelled H, I guess, for height. This is R, this is L, and this length here is 20 units. This length here is 30. And we're asked a series of questions. We're asked to find the length of H. We're asked to find the length of R. We are asked to find the length of L. Then we're asked to find the area of, and let me mark this, A, B, C. So we're asked to find the area of this triangle here. And finally, we're asked to find this angle in here. So those are all the questions. Now we'll get to my solutions for this. Now, the other thing that I must say is that this is going to be solved using right angle triangle trigonometry and Pythagoras. There are other ways of doing this, but this problem came to me from a student who knows basic trigonometry, sine, cosine and tangent for 90-degree triangles, right angle triangles, and Pythagoras. So this is how we're going to do this. Right, well, here is my solution. Now, you'll see that, first of all, this is a great deal neater, but in doing the drawing that I did earlier, I could see how this thing is put together, and it's a really great way of breaking into a problem, especially a geometry problem. Okay, so what have we got? Well, this is a right angle, which I should have noted. This we already knew at 125, this we knew at 20, this we knew at 30. I've marked that as theta, which I didn't on the other one. If that's 125, this thing is 55. So that's going to help us, because we're going to find H first. And how we do that is, as you see here, to find H, we note that the tangent of 55 degrees, which is this, is equal to the opposite over the adjacent, h over 20. A little bit of algebra, and we get 20 times the tangent of 55 equals 28.56. And I might as well do a live demonstration. So we have 20 times tan 55 on the trusty calculator. I hope you can see that. We do that, and that's what we get. It is 28.56 units long. I haven't bothered putting in units. Now, to find R, well, we have this, and we know this, Pythagoras. So, this is how we find this length here. So if I just pull this up, to find R, we note that R squared is going to equal, 50 squared, this length here, plus H squared, square root thereof. So R squared equals 50 squared plus H squared. R is going to equal the square root of that, which comes in at 57.58. So I'll just do this now again on the calculator. I'm going to use the the answer that I got here without rounding. I don't think it'll make much difference to what I've got written on the page. So what do I need to do? I need to square that and add 50 squared to it, which is 2,500, and find the square root of that, which is 57.58. I hope you can see that on there. The lighting is always a little tricky with this screen. So that's that. We can tick that off. Now, to find L, we do something very similar. That's our next task. And you can see that here. L, we can use Pythagoras again. We know this height, we know this length. This squared plus this squared will equal this squared. This is what it says here. Now, I should mention that certainly for this one, at this stage we could use trigonometry. We could go looking for what are we looking for? We could go looking for a side length. And so the cosine of 55 degrees is going to be equal to this over this. The sine of 55 degrees is going to be equal to this over this. We know what this is, so that's the only missing thing. But it's faster and easier to use Pythagoras, I think, so that's what I do. Okay, so h squared plus 20 squared equals L squared. L is going to equal the square root of those two, and that comes to 34.87. Again, I'll just demonstrate that quickly. What have we got? We've got 28.56 squared plus 20 squared, which is 400. And we find the square root of that. Here we go. And we get 34.86 and some change, 34.87. I hope you can see that clearly there. Okay, so that's our answer there. Now, the area of triangle ABC, this thing. Well, the way we do that is laid out here. We can find the area of the entire triangle. We can find this, height times base divided by 2. We can find this area, height times base divided by 2. This area here will be the total minus that. So let's do that without the waving hands. So area of ABC is equal to 50 times h. So this times the height minus 20 times the height. Both of these are divided by 2. I should say that. So this divided by 2 is equal to that. That is units squared. So we'll put that in we'll write it properly. And this is equal to this. Subtract this from this, and we get 428.4 units squared. Now, I did say that we could find some of these things by using trigonometry. In order to have done some of the earlier questions, we did need to know potentially what this angle was. And that's the last thing that we have to find. So we know this height, we know this length, we know this length. We can really take our pick. What I've chosen to do is to go for a tangent. The tangent of this angle is equal to the opposite, this over all of this. It's once we have everything that we need, this is one of the easiest things to do. So down here we have got angle BCA, which I've called theta. The tangent of theta is 28.56, which is the height, divided by 50. which is the base, which you can just see in the top of the picture. And I'll just do that quickly. Now, this is on a calculator like this. This is a second function job. So you can see what I've entered there. And I'll push go. And that gives me my answer. Rounded to 2 decimal places, it's 29.74. Okay, and that is how this gets done. So, I hope you found this interesting. If you did, please like and subscribe, and I will see you next time. Thanks a lot. Bye-bye.